The biggest aircraft development contracts likely to be awarded by America's military in this decade won't be coming from the Air Force or Navy. They'll be coming from the Army, which, after tinkering for decades with a helicopter fleet designed in the 1970s or earlier, has decided to make a clean break with the past. To counter great power competitors, the Army must operate in highly contested or complex airspace and degraded environments against adversaries with advanced integrated air defense systems. The Army is depending on the development of 2 new vertical lift aircraft weapons systems to help meet this threat. It might select an advanced tilt rotor offered by Bell Textron designated the V-280 Valor, or it might select the coaxial lift compound rotor helicopter offered by a Sikorsky Boeing team designated Defiant X. Either way, the service is likely to get the gains it is seeking in speed, range, agility, and endurance. Bell designed 2 modern, clean-sheet aircraft and evolved them into agile, low-risk solutions for the future long-range assault aircraft and future attack reconnaissance aircraft programs. Both weapon systems give the U.S. Army the proven, unmatched speed, agility and reach it requires to support the joint force in joint all-domain operations. Bell's future vertical lift aircraft will not only help the U.S. Army modernize, it will also grow and strengthen the U.S. industrial base. Bell V-280 Valor. Purpose-built to revolutionize the reach and effectiveness of each mission while offering unmatched maneuverability, reduced downtime and elevated mission safety. With over twice the speed and range as current weapons systems, the Bell V-280 Valor is the proven long-range maneuver solution, flying more than 300 knots and achieving more than 200 flight hours. Companion to the Bell V-280 Valor, the Bell 360 Invictus is the attack reconnaissance leader for the U.S. Army's future vertical lift program. Together, these weapon systems deliver mission-critical lethality, reach and sustainability. The Bell 360 Invictus is revolutionizing attack reconnaissance capabilities to enhance the ground maneuver commander's mission. The aircraft leverages a common open architecture digital backbone comparable to Bell V-280 Valor to give the U.S. Army an always-ready advantage with an unbeatable fleet. The new mission equipment won't just be used on the Blackhawk successor, it will also be used on a successor to the Kiowa Scout helicopter that is being separately developed by Sikorsky and Bell teams. Today the threat has shifted to near-peer nations, meaning Russia and China, so the Army no longer can put off replacing its Cold War helicopters. Some helicopters, such as Kiowa and Blackhawk, will be replaced sooner, while others such as the Apache Tank Killer, will be replaced later. But eventually all of the Army's current helicopters will be supplanted by a new generation of rotorcraft. Waiting so long to modernize creates serious operational concerns in Eastern Europe, where Russian air defenses have proliferated, and the Western Pacific where distances limit the utility of existing helicopters. However, there is a silver lining to the delay. The Army can now exploit breakthroughs like digital engineering and rapid software development to fashion new rotorcraft that were not available a decade ago. It is leveraging these breakthroughs to design and manufacture aircraft that will be cheaper to build and operate than legacy rotorcraft despite the big gains in performance. The differences between the Osprey and the Valor. The Valor has two engines, but unlike its larger ancestor, the Osprey, those engines don't physically move when the rotors they power change position, giving it a simplicity bonus over the V22. Only the rotors swivel. With the Bell V280 Valor, two engines push power to a gearbox system. Those two engines theoretically could be located anywhere on the aircraft. Even when they're both operating normally, the flight control computers determine how much power is taken from each engine to feed the system of gearboxes and driveshafts. Both engines power both rotors, and if one engine fails, both rotors still spin.